Let's do this. Okay, so we are in week something, week 10. And what we're gonna do in week 10 is talk a little bit more about arrays and functions. And I think I already mentioned some of these things to you last time, but I'll do it again. And for the interest of time, in the interest of saving time, I am going to go through the already written notes for the Monday lecture. So if you want to see me typing up numbers, look at the Monday video. So a quick review about arrays. What was an array? Well, it was a quick way for you to declare a bunch of numbers. For example, if you wanted to declare 1,000 numbers from A0 to A99, 999, then you say A square brackets 1,000 square brackets. The square brackets indicates that this is going to be an array, which is a list of numbers of all the integer type. The name of the array is A, and the 1,000 tells it that there's going to be 1,000 of these numbers. Initially, these numbers are not going to be equal to any specific value. There could be a bunch of garbage values stored in memory. So if you remember when I did a little for loop for this array of 1,000, lots of them were zeros, but there was a few just random big numbers in there, right? Okay, so if you want to, so this is declaring an array, but not initializing it. If you wanted to declare and initialize an array on the same line, then this is the syntax that will let you do that. You basically say the B square brackets, B is the name of the array. You don't put any number in the square brackets because the compiler will automatically figure out that since you're giving it 3 numbers here, then that it will need to make an array of 3 elements. Okay? Each of these are the elements of the array B. So this is the first element, this is the second element, this is the third element. Each of these elements are identified by their indexes. Okay? The index of the first element is always 0, and the index of the last element is always however many elements you have minus 1. So if I have 3 elements, then the index of the last one is going to be 3 minus 2, or 2. So this is my first element of the array, this is my second element of the array, and this is my third and last element of the array. Okay? If I wanted to display these array elements, then I just do a cout and I show the array elements like so. Right? So this is my first element, this is my second element, this is my third element, and so on. If I wanted to change these elements, then similarly I just make each of these elements equal to some kind of a number, and now they're changed. And then if I wanted to display them again, then you can see them, now they're changed. The power of arrays is that we don't have to do this repetitively. You know, every time you want to do something specific with an array element, you don't have to write a separate line for that. In fact, you can do one for loop and then one single cout, and that will show you any number of elements. Okay, so this one right here is basically going to generate a value for I, which is going to be equal to 0 initially, then it's going to go to 1, then it's going to go to 2, and these are the values that we're going to plug in here. So first we're going to plug a 0, then we're going to plug a 1, then we're going to plug a 2, and then the loop ends. Okay? So this is how you display an entire array using just 2 single lines of code. If I wanted to, this loop right here on the bottom actually showed you the initial values of that array, which were uninitialized. And so there was like a mixture of zeros with just random garbage numbers in there. So you can also use a for loop to initialize all of the elements in that. Right, so I have an array of 1,000 elements. I'm going to make my loop happen 1,000 times. So I starts at 0, goes to less than 1,000. That means it's going to generate these numbers from 0 to 999. We're going to plug in these values for I inside of the square brackets, and we're going to make every element equal to 0. So now my A array will, for real, legit, be equal to 0. Okay? You can have arrays of different data types other than int, right? As long as it's all the same data type, you can have an array of doubles, right? So here it is, it's an array of doubles. Okay, the index of these two, so this is an array of elements, of 2 elements. The first element is 0, always. The last element is 1 less than however many you have. 2 minus 1, that's the element of the last one. Okay? If you try to do things like trying to show an element that doesn't exist, like for example, this is what I'm doing here. I'm trying to show C out C2. Well, there isn't a C2, right? There's only a C0 and there's a C1. C2 doesn't exist. You might end up getting some kind of a crazy random garbage number like this thing here, which is what we got when we ran the program last time, I think. Okay? So be careful. In other languages, you will get an error, index range out of range. Index out of range error. In C++, you don't. Okay? It won't even crash the program on you. It would have been kind of nice if it crashed and gave some kind of an error message, but it doesn't. Okay? And that's just because of how the syntax for arrays is in C++ compared to some of these other higher level languages like Python and Java. Okay? In addition to, so just be careful, index out of range. Don't give the arrays an index that doesn't exist. Otherwise, you're going to get some unexpected numbers, that are stored in some random place in memory. Okay? You can also have a character array. A character array is an array of just single characters. In fact, the string itself, which is basically, remember, just the quotes and some text and then quotes, whatever's inside of the string is actually a character array. So the actual hello string that you're seeing here is literally an array that looks like this and ends with this \0. This is the null terminating character. And it's just built into the array object in order for your compiler to automatically know where to end this array. Okay? So in addition to an array of characters, you can also have arrays of strings, right? This is an example of array of strings. And you can show these different, array elements. And in here, what I did is I said, okay, let's show array 2, S array 2, which one is this one? What is this one going to show me? 3, right? Good. So this one shows 3, okay? Now, since character arrays are kind of built into the language, if I wanted to just say char array and just show the whole array like this, then it will show you just a hello just like this. So whether I say hello, the string, or the char array, then it will still show me the same results. Make sense? Okay. All right. Now the next thing that I talked about were pointers. Okay, so what are pointers? Well, it's a variable that has like a little asterisk in front of it. The asterisk tells it is going to be a pointer variable. Okay, these are different from the regular variables, right? The regular variables are used to store values in them, right? So there's a variable x which is equal to 10, there's a variable z which is equal to 100. This variable asterisk x is actually going to be equal to the memory address of another variable. That's what a pointer variable is. Right? So how do you get the memory address of some variable? By just using %x. Okay, so if I said %x, that will show me the memory address for this variable x, which usually will change. Every time I run the program, this memory address will change because the variables are not always stored in the same place in memory every time you run the program. Okay? But that doesn't really matter. Okay? You just say x is equal to %x, and then now pointer x is going to point to the memory address of variable x, whatever it is at that time when you ran the program. What's the advantage of this? Well, you can change this little variable x by changing the big variable x. So if I wanted to change little x here, I say asterisk x is equal to 100, and now this value here is going to be changed to 100. So when I do asterisk x here and I do a cout x, then I'm going to see that the value of x here is going to be equal to 100 because I changed it. Okay? I can also show the value of x through pointer x. If I wanted to do that, I just do asterisk x equals asterisk x, and that will also show me 100. Okay? Whether I say asterisk x or I say little x, I'm still referring to the contents that are stored in memory for little x. which is the 10 initially, and then I changed it to 100, right? Which is what both of these are showing me. Okay, if I had done a C out here, if I do a C out x equals x, right? And this here is going to show me a 10, which is what the value of x was before I changed it here. Okay, if I went in there and I said a C out asterisk x equals, then I'm going to see that asterisk x here will also show me the value of 10. Right? In other words, as soon as I point big X to little x, now I can refer to the value stored inside of the memory slot for x by the pointer variable itself. And I can also change it like doing so. Okay? Any questions? Okay? So, pointers can be repointed to different variables. Right? So initially I had x is pointing to little x, and then here I'm saying x is equal to %z. So as soon as I do that, now big X, the pointer x, is going to point to this variable z, so that I can change it similarly to how I changed x if I wanted to. Okay? The pointers are actually used when we pass an array into a function. Right? So if I have by the way, all these arrays that you're seeing here, these are one-dimensional arrays. Okay, so if a one-dimensional array, let me pull my little Excel spreadsheet to show you. If you have a one-dimensional array, right? A one-dimensional array, if you have a numbers like 1, 2, whatever, 2, 3, 4, right? So this would be like, say, an array A, like that, right? This is a one-dimensional array. If I wanted to do something like this, 5, come on, tab already, 6, 7, 8, right? Now that is a two-dimensional array, right? And how am I going to make a two-dimensional array? It will be something like B square brackets, square brackets. So that's a two-dimensional array, right? So a one-dimensional array was something like A, like that. And then each of these numbers here indicates what number of column we're working with. So if I say 0 here, then that's this one. If I say 1, it's this one. If I say 2, it's this one. For this two-dimensional array, right, which has rows and columns of numbers, if I wanted to refer to this number, then that will be actually number 0, 0. Okay, so this is my 0, 0, column 0, row 0. Okay, if I wanted to go to the next one, this one here, right, then that one will be B0, 1. Okay, so this number here, the 2, is B0, 1, if I wanted to do that. If I wanted to go to, like, say, this number here, what do you think that's going to be? I'm going for this. What do you think, Rigo? 3 what?
B03.
B, well, there's only 2, so it goes like this. So this is column 0, column 1, column 2, right? So when I was talking about this one, when I said I want this one here, the 2, then I said this is 0, 1, right? So row 0, column 0, 1. So now I'm going for this one. It will be 1, you got that one, and what about the other one? Remember, it starts at 0, 0, 1, 2, and then the other one will be 2. Yes, all right, so that's the red one. Okay, so those are two-dimensional arrays. Okay, whenever we're talking about a one-dimensional array, another way to write this is basically making an asterisk A, right? So a single pointer like this would be how you create an array in C++. Okay, so we're telling it this little asterisk A is going to point to a whole bunch of variables, to a list of variables, and it basically just indicates the first element of that array. Okay? If I wanted to do a two-dimensional array, then it will be something like B, asterisk asterisk B. So it's basically a pointer to another pointer. So it's like a two-dimensional array is created using double pointers. Okay, but don't worry, we're not going to get into that. I'm not going to torture you with double pointers at all. But I want you to be aware of them because this is how we're going to be passing arrays into functions. Because arrays, they don't necessarily just have to be of the type of these basic data types, the primitive data types that we are used to, right? You don't have to have just an array of doubles. You can create, later on, when I show you objects, you're going to learn that you can create your own objects and you can make arrays of these objects. And since objects can be really, really big things and they take up a lot of space in memory, it's hard for you to grab like a collection of objects and just move them around. And that's the reason why you have a pointer. So when you're going to be passing an array into a function, you're going to be passing a pointer to the array location. So you don't move the whole thing, but you just have a reference to where that array is starting. Okay? So that's the whole reason I'm talking about pointers here. That'll be the main reason. Okay? And then the other thing that I need to tell you about this week is, and I probably talked to you about this last week also, I don't know, is different ways to repeat something. Right? So you can have a for loop, which is going to show you the values of I are 0 or equal to 0, 1, 2, right? You can have a while loop that will do the same thing, right? I starts at 0 while I is less than 3, I plus plus, and then show the I every time. So that will show you this business here, right here on the bottom. And then also, and I'm pretty sure I talked to you about this last time, you can do the recursions, right? What was a recursion? A recursion was a way for a function to repeat itself, to call itself until some final condition is met. Okay, so let's have a look at the recursive function real quick. Going down, going down. Where are you, recursion? There's the recursive function, right? So how does the recursive function work? You're going to show the value of them. So initially we're calling this thing with a 0, right? I show you the 0, and then is 0 less than 2? Well, yes it is. So call yourself with 0 plus 1. Then we go to the next iteration of, or next instance of that function. Now it's called with a 1. I'm going to show you the 1. Is 1 less than 2? Yes it is. Call yourself with 1 plus 1. Then it's going to show the 2. Is 2 less than 2? No it isn't. And then it stops calling itself. Okay? And I also illustrated to you last time how if I grab this thing here and I just moved it at the end, right? Things changed. And how did things change if I move this here? It goes the opposite way, right? And if you missed it, go look at my video from last time. I went in detail and drew pictures in Excel and all that good stuff, right? I don't want to do it again. So look at the video from last week, Thursday, for the recursion in more detail. But basically what happens is, let's say the original one was, recursive was 1, 2, 0, right? If I move this here, it becomes 2, 1, 0. And the reason for that is, let's say we start with a 0. We're calling the function with a 0. Is 0 less than 2? No. I mean, yes it is. Call yourself with a 0 plus 1. Goes back as a 1. Is 1 less than 2? Yes it is. Call yourself with 1 plus 1. Then it goes the last time. Is 2 less than 2? No it isn't. And then it's done with the calling part, but then there's still something left, and what's left is this last statement right here, which is where I'm going to show the number. So the last number that I'm going to show when I get to the 2 is the 2. Then I get to the end of the function that was called with the value 2, and I return back to the previous place where I was called, which was for a value of 1. I show you the 1. I get to the end of the function. When I get to the end of the function, it goes back. Now it returns to where it was called, which was the original function. It was called with a 0, right? And then it shows you the final 0 in there. Okay? So recursion is very important. Make sure you understand it, because it's going to come to haunt you in the data structures class when the data structures comes. Okay? Even though I'm not going to do a whole lot of them in this class. I think I have you do the 99 bottles of beer on the wall with recursion or something like that. So So that's recursion. Okay, so now the other stuff that I wanted to show you is how, where's my array? Yeah, let's look at the order of things here. So okay, so first of all, remember that every time I wanted to show my array, let me see where's my array show array. Here's the show array, right? So if I wanted to show my array, let me just copy this. Alright, show array here. So if I wanted to show the array, then every time I have to do something like this, right? And that's a lot of code, maybe. To me, I don't want to write 1, 2, 3, 4 lines of code every time I want to do this, right? And then actually there's another one that goes at the end, cout, like a little this, right? So it kind of gets, the code becomes less and less clean. So it will be nice if I can just get this whole thing and put it inside of a function, and every time I wanted to show the array, I just call the function like I'm doing here. Okay, so how am I going to do that? Well, let's look. So show array is my function. Let's look at the array of the show array prototype. So this is my prototype for the show array. Okay, what does the show array take? It takes a numbers array, it takes the size of the array, and it takes some kind of a parameter called reverse, which I'm going to use to show you the array in regular order or in reverse order. Because why not? If I'm going to build a function, I want to be able to do it, show the array backwards and forward anywhere I want. Okay? So this is my prototype. All right? Now let's go look at this function definition. The function definition, same thing as the prototype minus the semicolon, and in there I have my little k, the whole business that I had in the main, right? Is in here. So what I'm saying is if my parameter reverse is true, right? This is what this means. And another way to rewrite this is this way, but this is shorter. Since the reverse parameter is either true or false because it's a Boolean, then I don't have to write it this way. I can just say if reverse, which is going to be either equal to true or false, then show it in reverse order, right? If I wanted to show the thing in reverse order, I want to start at the last element. Remember, the last element of an array is always the size of the thing, -1. And I want it to go on while it goes to basically the 0 and backwards. Okay? And then the reason I'm declaring k outside of the loop is because once the loop is done, it will do one extra step. So the loop here is going to show me, let's say I have an array of 4 things, right? It's going to show me 3, 2, 1. It's not going to show me the 0. And then when it gets to outside of the loop, then it's going to show me the 0 and then the end of the array. Okay, with the curly bracket. This is if the reverse is true, right? So this is me showing the reverse of the array in reverse. If the reverse is false, then that's automatically we're going inside of the else. And in the else is where we're going to do the show the array in regular order, not in reverse, right? And if it's in irregular order, you start at 0, and you want to show, for array of 4 things, I'm going to show 0, 1, 2. I'm not going to show the 3, that's why I'm stopping this thing at size -1, so that I show every one except the last one separated by comma, and then the last one is going to end with a curly bracket and an end L. Okay, so it's just a clever way for you to show an array of any size in regular order or in reverse order. It's up to you. Okay? Now, as far as, does this make any sense? Any questions? Going once? Going twice? 2.5? 2.6? We're good? You sure? 100%? I'll take your word. Okay. So show array is a function. Now let's see how we're calling that function. Well, the first place where I'm calling it is right here. And notice what I do. I am sending the array D. I'm not putting square brackets. I'm not putting a number in there, right? I'm sending the entire array. Okay? And as soon as I do this, I'm actually sending a pointer to the original array. Okay? So if I was to run this program, hopefully it works. How many numbers do I want to enter? I don't want to enter any numbers. What are you talking about? Where's my array? Oh, that's a lot of stuff. Whoops. Wait. Where's the array? Damn it. Show array. Damn it. Hold on, let me get rid of this stuff here that was just a bunch of extra things. This piece. And let me run it again. I think that was some example. Where's the CN that I have? Oh, that's this. Yeah, okay, so let me take out this piece too. Well, okay, so this piece here is asking the user to enter the size of the array and then asking them to enter that many numbers into the actual array. So I'm going to take this piece out. Hopefully the rest doesn't break. Yes, it did. So let's do this. And numbers is equal to 1, 2, 3, 4. Okay, and then I'm going to take out this piece. All right, because I need an array of 4 things so that I can show it here. All right, run it again. Damn it, number size. And take this out and change it a little bit. No, I forgot the semicolon. No, that's not it. There you go. Let's try it again. There we go. So the whole point for me was to show you the array. So here it is. I'm calling show numbers. I'm sending the entire numbers array into the thing, and then I'm showing it to you in regular order and in reverse order. Okay. So that's the point of, that's how we send an entire array into a function. Okay. Now one thing that I want to show you is another way to do this, and that is to illustrate how arrays are sent as pointers. So instead of show array here, what I'm going to do is I'm going to write another function. This is my other function here, right? So this function is called show array 2. It takes a pointer for numbers, not an array like we did here, and the rest of it is pretty much the same as the one on top. Okay? And if we jump to the function definition for show array 2, you're going to see that it's pretty much, not pretty much, but it is identical to the one on top of it, right? So in here I'm sending an array, in here I'm sending a pointer, and in here I'm telling it to do basically the same exact thing, no different than the one that I have on top. Okay, and what you're going to see is that it will actually work the exact same way, whether I do it as a pointer or whether I do it to tell it to send the array like this. It is the same, it will do the same exact magic. Okay, so to convince you, not sure where to show this thing. So I'm going to do it right here. Show array 2, whoops, 2. I think that these are the last 2 that I needed to, come on. Yeah, so I'm going to run this thing again. And these lines of code here, I mean, this show array does this 1, 2, 3, 4. That was this one, and then the other one was this one, right? So when I run it with the pointer function, I should get the same exact results, and there you go, the same exact results. Okay. So what's the moral of the story? The moral of the story is that whether you're sending an array into a function as a pointer, or like this, it's pretty much the same thing. Okay? Any questions? Okay. So the next thing that I want to go into this stuff is, and these were some of the hints from, I don't know, maybe last time. Was it? 53, yeah, that was last time. Okay, so I'm gonna skip through these. 54. And yeah, pass by value, pass by reference, pass by pointer. Did I go over this stuff last time? No, Heidi. All right, let's go over it again. So let's say we have a variable k here, right? K is equal to 78. Then what I'm going to do is I'm going to show you the value of k. Then I'm going to call the function pass by value k, right? And where's, I know I did it, but let's just do it again. So bubble pass by value is this, right? So what I'm doing is I'm telling it, okay, variable k is equal to 100 here, right? And then what is going to be the value of my k when I do a cout here? So remember, inside of pass by value, I'm saying k is equal to 100 or whatever. But then when I do a cout here, what I showed you last time, you will see that variable k 78 is not affected. It's still 78. And why is that? It's a local variable. Yeah, it's a different. Both of the variables are stored in different place in memory. Okay. So even though there's a variable k inside of the main, and there's a variable k inside of pass by value, changing one of them does not change the other one. Okay. But there is a way to do that, and that is done using the pass by pointer. Okay, what's the pass by pointer? Well, you're going to be passing a pointer, right? Here's my pass by pointer, right? So unlike the pass by value where I just have a k, the pass by pointer has an asterisk p, and asterisk p is going to be a pointer to some other variable. So when I do pass by pointer, what is inside my pass by pointer? Pass by pointer is right here. So I have, this time it's not even called k, it's called p, and I'm saying asterisk p is equal to 100. But since this is going to be a variable that points to the memory address of k, which is in the main, then by doing asterisk p, this actually changes the k inside of the main, right? Just so similarly to how I had, where my pointer example that I had? Similar to how I had a little variable x, and I'm saying big X, the pointer x, is equal to the ampersand x, which is the memory address of little variable x, and then I can change the little x with the pointer. That is exactly what I'm doing when I do pass by reference. Well, I mean pass by pointer, right? So I have a pointer p, I'm sending ampersand k, so I'm sending the memory address of k, so now p points to k, and if I change p, I'm changing k. Okay? There's another way to do this, which is the pass by reference, and I did go over this thing last time, which is the part that Ellen started laughing at, right? Because I was throwing like every complicated subject at you at the same time. So pass by reference is similar to how you do a pass by pointer, right? If you look at it all the way on top, pass by reference, we have an ampersand p, right? And ampersand p is pretty much similarly to how we do a pointer. Okay, so this thing is still going to take a memory address of a variable, but the syntax is different. Okay, in one you have to do an asterisk, and in the other one you have to do an ampersand. If you do an ampersand, then pass by reference, the actual code is like this right here. Okay, so instead of doing an ampersand key as we did with the pointer, when we're doing pass by reference, which is the one with the ampersand parameter up on top, we just say k. That's just the syntax of the language, right? Just the way it is. You remember C++ has a million ways to do the same thing. There you go. There's another one. Okay, so you might ask yourself, then what's the difference between pass by reference and pass by pointer? Well, when you have a pass by reference, which is this thing here, the variable or the reference variable p is connected permanently with the variable that you have sent over from the main. In other words, p here is permanently tied with the k inside of the main. I cannot tell p, okay, will be equal to the memory address of some other variable. It can't work that way. Okay? So in other words, it's kind of like creating a shortcut. You know, like the shortcut to k is the same is p, right? And it's always going to be that way. Okay, I cannot change it. But if I have an asterisk p, which is a pointer, which pointed originally to the k inside of the main, I can repoint my pointer variable to another memory address if I wanted to, which is why I created this thing here, right? So if I have an asterisk p, I can change the variable to which p points, like so. Then I can have some other variable, and I can tell p, okay, well, be equal to the memory address of this other variable. So I have repointed the pointer to something else, something that I cannot do to a reference variable. Okay? Any questions? This is a lot of heavy stuff, so I hope you're paying attention and getting it. All right. So now you know pass by reference, pass by pointer, pass by value. A lot of people don't get these. A lot of people think these are like very complicated and confusing, which they are if you don't put in the time and effort to understand them, which is on you. Okay. So what else? What else do I want to tell you? Oh, well, the other thing that I want to tell you is that remember the example that I had in here. We can show an array by sending the array over or by sending a pointer to the array. Okay? Because of how arrays are sent into functions, which is as these two functions demonstrate, arrays are sent into functions as pointers. In other words, the pointer variable numbers refers to the array of elements that is somewhere else in the program. So I can see that array of elements, but I can also change it through my function. Okay, so just like I changed the k in my main using asterisk p, that is exactly how I can change my array if I wanted to using a pointer, right? So in order for me to do this, I'm going to do the bubble sort. Okay, so in order for me to show you the bubble sort, did I show you the bubble sort last time? I did. Okay, go. So just a quick review of the bubble sort then. Okay, so how does the bubble sort go? The bubble sort, you have a list of numbers, right? So let's say this is my list of numbers or an array of numbers, and I would like to sort this thing in ascending order, right? And I showed you last time with the picture with the bubble sort and on Wikipedia, so if you missed that, look at my video. And from last Thursday. So bottom line is we're trying to sort this thing, and the way we're going to do this is we're going to compare every two numbers next to each other, right? First we're going to compare 4 to the 3, then we're going to compare these two in the middle, then we're going to compare the last two. Okay, and if at any time any of these two, if the left one is bigger than the right one, we're going to swap their values. Okay, how do we swap values? Well, you make some kind of a temporary variable. So let's say, for example, you have these two variables here, g and h, and you're trying to swap their values so that g is equal to 2 and h is equal to 1. You make some kind of a temporary variable, which is equal to g is equal to h, and then h is equal to temp. And when you do that, you swap their values. Okay? And then again, more details for that. And if you want to see me type numbers, look at the videos from last week. Now, this idea is what I'm going to be using to sort the array of things, right? So what I'm going to do is I'm going to compare the left to the right. So D0 is the left one, D1 is the right one. If the left one is bigger than the right one, then swap their values, right? So if I started with this thing as 4, 3, 2, 1, as soon as I do a swap, and I call my show array function here, which shows the array in its regular order, then it will show it as 3, 4, 2, 1, right? If I go in there and I do it again, if I swap now the second one to the third one, so now I'm comparing these two numbers in the middle, right? This is my number, this is index 1, this one here is index 2. So the 4 is the 1, the 2 is 2, okay? Then I swap their values again if the left is bigger than the right one, which it is. And then the 4 moves 1 to the right again. And now the last thing that's left to be done is compare the last two elements. And what are the last ones? This is 0, this is 1, this is 2, this is 3. Right? So now I'm comparing index 2 to index 3. In other words, if this one is bigger than the other one, we swap their values. And when you're done swapping this, then the 4, this thing at the end will look like the 1's going to go here, and the 4 goes there. Okay, so this was just the process that we have to go through to move the biggest number to the right, and this is just for 3 numbers. Okay, but you don't know if there's going to be 3 numbers or 5 numbers or 10,000 numbers, and you definitely don't want to copy paste this thing 9,999 times. So what you're going to do is you're going to say, all right, hold on, let me look at the pattern. Well, this thing happened 1 time, 2 times, 3 times. Okay, that's good. What are the values that I put inside of my square brackets? Well, this one was a 0, this one was a 1. So if I call the 0 an I, then I can call my 1 I plus 1, right? And then look at how my I changes. It was 0 here, then it went to 1 here, and then finally for the last one it went to 2. Okay, so I know for any array of any size that it will always start as a 0. The tricky part is to figure out where it ends. What if for an array of 4 things it ends at 2, that tells me that this number here is actually size minus 2. Since size is 4, there's 4 elements in my array. All right, 4 minus 2 is 2. That is the value for the last. This is where I is going to end. All right, so I know that I starts at 0, and I know that I ends at size minus 2. Okay, which lets me write this loop right here. Okay, where the I starts at 0. And the I is less than size minus 1. Remember, if I just had it as size, then it will make variable I equal to 0, 1, 2, 3, right? Since size is 4, this thing is going to go from 0 to 3. But since I wanted to go to 0 to 2 for a size of 4, and then I do a minus 1 in here, and now it goes from 0 to 2. And at that point, I can literally grab one of these here, right? And since this thing was my I, and the other one to the right, it was I plus 1, I just write the if using an I and an I plus 1. And by doing by doing this here, what's going to happen is you're going to see that at the end of this one, this loop will do the same exact thing that these 3 separate ifs that I had on top did. Okay? So I have found a way to simulate, to make this process automate itself for any number of numbers. Okay? Then what I showed you was, okay, well, this was just to move the biggest number to the right. If I wanted to move the second biggest number to the right, then I would literally have to grab this whole loop here, copy it, paste it again, and then when that's done, then the thing looks like the 3 is going to be in somewhere in here, right? And maybe the 2 is going to be here, and then maybe the 1's going to be here, right? And then if I wanted to do it one more time, if I just copy pasted this loop one more time, then the final thing, it will look like basically the 1's going to be at the front, and then we're going to move the 2 to the right, and then at this point the thing is sorted. Now that I have done this thing 3 times, it's time for me to figure out the relationship so that I can automate this for an array of any size. Unfortunately, I had to repeat this thing as many times. So if I had to repeat this process on top 3 times, I also had to repeat this process here 3 times. Which means that the way for me to repeat this loop is the way that this loop repeats itself. So if I was to just basically create another loop, call it, make a variable j, right? Which starts at 0, goes to size minus 1 plus plus, and in it, I threw this other loop in there, then the outer loop is going to make the inner loop repeat 3 times for these 4 numbers that I had, and then I'm going to have a sorted thing if I wanted to. Okay? I'm not sure if I pointed this out to you last time, but if you look at the bubble sort, all right, if you look at the bubble sort, remember the first time we go through this pass, right, we're comparing left to right, and what's going to happen is the first time we go through this, the biggest number gets moved all the way to the right, right? Then when we go back to the beginning, I no longer have to go all the way to the right because I already moved the biggest number all the way to the right. So the second time I go through this process, I only go I go one less time than the previous time. In other words, I don't have to go all the way to the end. The biggest one is all the way at the end. I need to go one less than as far as I went last time. Okay? So once I move my 8 to the end, right, I'm going to go back all the way to the beginning, and I'm going to repeat this process, but I no longer have to compare the last two elements to each other because the biggest one is all the way at the end, no point to check. That is the reason why I added a little minus j here. So what does the minus j do? It makes this loop, the inner loop, happen one less time as the outer loop increases. So the first time we go through the loop, the outer loop, j is equal to 0, so the inner loop is going to happen size minus 1 times, because j is equal to 0. The second time we go through the outer loop, j is equal to 1, so the inner loop is going to happen size minus 1 minus 1, so 1 less time than before. And so on and so on and so on. So this is just a way to improve the efficiency of my bubble sort. Got it? I hope. Any questions? You don't have to all ask at once. Okay, so now that I have this bubble sort thing figured out, I said, well, why don't I throw it inside of a loop? Why don't I throw it inside of a function, right? I'm going to make a function. I'm going to call it bubble sort. Where's my bubble sort? This is my bubble sort function, right? I'm going to make some kind of a variable for an array. I'm going to give a size to this array, and I'm going to do it similarly to how I did the show array function. I'm going to use a reverse so that I can sort this thing if I wanted to in ascending or descending order. Right? So you want to sort this thing 1, 2, 3, 4, you can do it. If you want to sort 4, 3, 2, 1, you can do that too, just based on whatever this variable here is. Okay? So let's jump to the bubble sort implementation. This is my bubble sort. So if I'm not sorting this in reverse, I'm going to compare the left to the right. Okay? And if I do want to sort this thing in reverse, all I got to do is I got to flip this thing around. So if variable reverse is not equal to true, or it's equal to false, or another way to rewrite this is just saying not reverse, which is basically the same as saying this, right? Then I'm going to show it the way I showed it to you in the example that I did so far. Otherwise, else means this isn't true, so that means I'm going to sort it in reverse order. And if I wanted to sort the thing in reverse order, these loops stay exactly the same. This piece stays exactly the same. This piece stays exactly the same. The only thing that changes, I'm just flipping this. So I'm changing just this to that. Okay? And now I have this thing summarized in a nice little function which allows me to sort the thing any way I want. Right? I want to sort ascending. There it is. So where's my call? Right here. So I am sending an array D of size 4, and initially I'm telling it to sort it in ascending order. And then I'm showing the array false. Remember, false was show it in regular order. This is my array that after I've sorted it. Then I do a bubble sort, this time true, sorted in reverse, and then the array is going to be sorted in this way. One important thing to notice in here is that the array is being changed inside of the bubble sort. So just like I could change a variable using a pointer inside of a function, whenever you send an entire array into a function, you will be able to change that array. That's very important. Okay? Any questions? Okay. Some other things that I might have not told you were how to find the minimum. Well, of course, you can sort the array and then look at the first or the last or whatever, depending on how you sorted it. And then that will be the minimum. Or you can just say, all right, well, the minimum is going to be equal to the first element. And then look at all the other elements. That's what this loop will do. And look at if any element is less than the min, which was originally equal to the first element. And if that is true, then make the min equal to that element. Very similar to how you had to find the min and max earlier in the previous assignments without the race. There it is for arrays. Okay? And yeah, so that was, I'm not sure which example. 55 hint. Oh, so 55. is first one. Okay, so that's pretty much all I wanted to tell you. So the swap example, the bubble sort, arrays and functions, I showed you all that stuff. Do you remember that an array is being sent into, an array is being sent into a function as a pointer. So changing the array inside of the function changes the original array. Okay? And you're not sending the entire array of things into the function, you're just sending that pointer which points to the actual array. Okay? Alright, so 55. 55 talks about write a function which, given an array of integers, returns how many times the number 2 appears in the array. Okay, so here's an example. So first of all, and by the way, if you want to find the size of any array without looking at the actual, counting the individual elements, this is how you're going to do this. Right? So let me look at this real quick so I can show you how it works. So I'm going to comment this piece out. And let me show you a little something. So let's say I have a character array. Oh yeah, I had it from before. So the character array that I have already defined is, in fact, let me just make some other array. I want to do it right here. Int sum array, and this thing is going to be equal to 10, 20, 30. Okay? So I'm going to show you a couple of things here. So first of all, let's say I have, and this is actually kind of interesting. So I'm going to do I'm surprised I didn't have it somewhere in there. No, okay, whatever. So what I'm going to do is, first I'm going to do a cout ampersand, let's just do sum array, like that, and L. Okay? And let me just show you the thing. Okay? So let's have a look at what this thing is equal to. Some array is equal to some variable. Some memory address. Right? So what I'm looking at this here, I'm actually seeing this. Okay? It's just some memory address. Okay? Now let me do this. I'm going to say cout ampersand sum array 0 equals. And then I'm going to do ampersand sum array 0. Okay? And L. And I'm going to do the rest of them too. So this is 0, 1, 2, and then again, remember my indexes are 0, 1, 2, right? Okay, 0, 1, 2. Okay? So I guess let me go back to my Excel spreadsheet. Alright, so I have sum array. So if I set sum array, this thing shows me some memory address like this, right? Actually, let me just run the program so we can look at the new numbers because they're going to change. Okay, so if I say sum array, it shows me this. Okay, if I say these other ones, if I say this, let me just get this thing here. If I say this here, then that one is actually the same as the other one. Okay, they're the same. Then if I go to the next one, sum array 1, right? Then this one, then I get this number, this memory address. Now that one's a different one. Then if I go to the next one, 2, then I'm going to get another number, which is this thing here. Okay? So you notice some kind of a relationship in these numbers? How are they different from each other? These two are the same, right? But then what about this one? This one is basically the same exact number plus 4. Yes? Then the next one over is the next number, which is plus 4 again. So remember, we had said sum array square brackets equals, and then you had let me do the curly brackets in there too. Alright, is equal to, then you have a 10 here, 20, 30, and then you have your curly bracket at the end, right? Okay, so sum array actually, the variable named sum array refers to the beginning of a sequence of memory addresses. Okay, that's what the purpose of this thing, that's what this is showing you. So in other words, the memory address for this place is this, right? The memory address for the next one over is this, and the next memory address after that is this. Okay, so these are the memory addresses of the different elements. When I just say sum array, that refers to the beginning of where this thing starts, right? What I can do is I can look at the, and by the way, why do you think they're in increments of 4? What do you think the 4 is? Four trees, 4 apples, 4 cats. What could the 4 be? 4 bytes, right? So each memory address is off from the previous one by plus 4 bytes. Why is it 4 bytes then? That's the actual how much space each integer takes up in memory. By definition, an integer is 4 bytes. How many bytes do you think a float is? 4. Okay. How many bytes do you think a double is? 8. So a double is twice as many as a float. All right. So there you go. So now what we can do is we can actually figure out. We can tell. Let's have a look at the size of this whole thing. So I'm going to say cout size of, and then I'm going to put sum array here. Okay, so size of sum array and L, and let me put a little label in there. Okay, so when I do size of sum array, let's have a look at this thing. Size of sum array is 12. All right, so this thing here shows me 12. So what do you think the 12 is? I don't know. Huh? 12 is 4 plus 4 plus 4. There's 3 integers, each of them is 4 bytes long. So when I say size of sum array, and it gives me 12, this is the size of the whole thing in bytes. Okay? So this is size of the entire array in bytes. Okay, and how many bits is 1 byte? How many bits is 1 byte?
Is it
8. 8. Awesome. And what's a bit?
0 and 1.
Okay, 0 and 1, and that is the smallest piece of information that the computer can store. Okay. All right, so we know there's 12 bytes in this thing, right? And we can also tell the thing to look at the size of the individual element in there. So this is 12 bytes total. And if I do sum array, just pick one of the elements. Let's go with the first one. Sum array 0, right? This is one of my elements. Then it's going to show me the array, the size of one of these is 4, which is the size in bytes of one of the elements. Okay, well I know that one of them is 4 and I know the total is 12. So if I was to just divide this number by this number, what do I get? However many I have, right? So if I've divided by 12 divided by 4, I have 3, and that is the number of elements in my array. So you no longer have to go in there and count things manually if you don't want to. Be my guest if you want to, I don't care. All right? So now that we understand how the size business works, let's have a look at this here. So I have a size of character array, and I have thrown the character array in there. All right, so that's my character array. And this is your hint for, I have no idea. What is this thing here? Oh, this is 55, yeah. So 55, I'm looking for how many times the number 2 appears in the list in an array of any size, right? So could be any size array, right? So make up different arrays with different sizes, throw a bunch of different 2's in there, maybe no 2's at all, and see if how many returns, right? So this first array right here, which does not have any 2's in it, should return a 0. The second one that has 2 2's in it should return 2, and this last one that has only one of them should return 1. How do you do that? Simple. You figure out the size of the thing, make a loop that goes from 0 to the size, and then look at if any of these array elements are equal to, in this particular case, I'm looking to count how many times the letter L appears in my character array, right? So every time one of my elements is equal to the letter L, I count it. And I start my count equal to 0 initially. Yes?
Yes.
Okay. If you say so. So, you convinced me though. 56, bubble sort. I pretty much give you that one. Okay? 57, min, max, average. Well, this is how you find min, right? So this is your 57, I guess, hint right here. All right, this is P57 hint, right? This is how you find the minimum. You should know how to find the sum and the average and all that good business. You have any questions on how to do that? I hope not. Okay, so it's basically the same way you've been summing up numbers up to this point. Make sum equal to 0, go through all the elements, add them one by one into the sum, and you're done. All right? Okay? So then 58. 58 talks about given an array of integers, return true if 6 appears as either the first or last element of the array. Okay? So if there's a 6 at the end, this thing returns true. If there's a 6 in the beginning, this thing returns true. If the 6 is not in the beginning or the end, the thing returns false. Okay? So how do you look at the first element? Well, if the first element is equal to 0, right? So if you have if D0 is equal to 6, right? That's the first, right? Or if your D size minus 1 is equal to 6. That's the last one. Okay? So comparing the first and the last, if that's true, return true. Otherwise, return false. Okay? So that's that one. That's not that hard. The next one is, let me zoom out of this thing. 59, common end. So you're giving 2 arrays, array 1, array 2, right? And 2 different sizes. By the way, to warn you, you will not be able to find the size of an array once you send it into a function. You can calculate the size of the array wherever it is in your program that you you declared it. Right? So if my array is declared in the main, I have to find the size, and then I'm going to send the size as a variable into my function. Okay, I cannot calculate the size correctly inside of my function. You can try, and if you can do it, I'll give you like a tap on the shoulder or something, and a gold star, and then maybe some fruits and vegetables for you, some carrots. Okay? So,
Is it organic?
not organic. The organics is extra. You have to do some even more for the organic carrots. Okay. Or I'll think about it. We'll see. So, okay. So, finding common ends, right? You have an array 1, you have an array 2. You're trying to see if one of them is equal to, if the beginning of one is equal to the beginning of the other, or if the end of one is equal to the end of the other, right? So that is this thing here, right? So if the beginning of one of the arrays is equal to the other one, that's one thing. Or if the D size D minus 1 is equal to my B size B minus 1, then they also have common ends. Okay, so this is the common ends. All right, and this is to see if 6 is first or last. Okay, so that was your 58, 59 hints. Is there a 60? Bull? Yeah, okay. Last one is given an array of any size, return true if it does not contain a 2 or a 3. Right? So you're going to have to make a loop that goes through the array if any of the array elements, kind of like we did with this, right? So if you can have something like, say, count 2's, instead of count L's, you can have one for count 2's, and then you can have another one for count 3's, right? And inside of this array, inside of the loop, if this is equal to 2, count the 2's, right? And then have another if in there. If this is equal to 3, count 3's. And then go, at the end of this whole thing, when the function is done, look at, if, so this is your hint for 60. P60 hint. Right? So this one is basically if your count 2's is equal to 0 and count 3's is equal to 0, then return true. Make sense? Because you didn't find any 2's and 3's, return true, otherwise return false. Okay? Any questions? All right. Let me go back to this week and see if I want to tell you anything else. Yeah, min, max, average. Oh, what the hell? Let me just show you the average too, real quick. Lower the sum. Where's that thing? All right, so here it is. So what I'm going to do in here, I'm going to have an int sum is equal to 0, right? And then here, I am going to do another thing. I'm just going to say sum plus equals, well, not 0, I'll make it d0. So make sum equal to the first element, and then add up all the other elements into it. Okay? And then to find the average, right? Average is equal to the sum divided by the size of the array. Okay? And you do that. Any questions? Okay, you will have them when you get to it, I'm sure. So, that is pretty much all I want to tell you as far as arrays and functions are concerned. This stuff is very important. Again, make sure you understand it. This is pretty much, by the way, as far as you need to understand to get an AND class, right? If you get up to this point, you got arrays, then you will be able to do the final project. And the final project is assigned in week, I don't know what, 12. Right? So next week we're going to do practice, extra credit assignments. I'm making the week 11 extra credit for people who are procrastinating and taking their sweet time. Okay? Yeah. But it's extra credit. Even though it's extra credit, make sure that you do all of them. Okay? It will be really good for you if you do them, because then the next week, week 12, some of these extra credit assignments will have to be in your final project. So the final project, you can look at it. It's pretty much all arrays and functions. Right? So it's 100 points worth, and a lot of it is the stuff that I showed you already. Right? Show the original array, show the array in reverse, find the lowest value, show the highest value, sum of all the numbers, average of all the numbers, how many times a certain number appears, show the difference between the first and the last, then show the elements of the array before a specific index. So if you've done the homework up to this point, chapter 10, you can pretty much go and do the final project, and you'll pretty much have an A in the class. Okay? So that's how I've set it up. And other than this, we're also going to talk about files. Files are different ways for you to enter information into your program and output information from your program. we'll talk about structures, which is these more complicated ways for you to structure your code. And then after that, we'll talk about classes and object-oriented programming, which is a little bit more complicated way to organize and structure your code. And then we're done pretty much. Then we do CSS 46, which is lots of fun if you haven't done arrays. Okay?
What's 46?
CSS 46 is the data structures class.
Oh.
And the data structures class looks like this. So you have a little introduction in the beginning, then we'll start talking about data structures, then encapsulation. Notice how we're starting with arrays right away, right? There's a bag data structure, there's different types of sorts, right? So it's basically different arrangements of data based on some real life situation. Like maybe you want to have something that simulates a stack of plates where the last thing is always put on top and the last thing that we put on top is the first thing that we're going to take off. Or maybe you want to, that's called a stack. Or maybe you just want to have a random collection of things and you don't really care about how in what order you put them in and take them out, but you want to be able to know how many things are in it, and if there's a certain thing that's in the collection of items, that's called a bag. Then there's also queues. What's a queue? Well, is basically a line of people, right? The last person that comes in comes at the end. The first person that leaves, or the one that leaves, is the one all the way at the front. So first in, first out, basically. So that's the algorithm for this one. This one is last in, first out. So basically, you come up with some kind of a real world scenario, and you think of how we can arrange this real world scenario, which is the abstract data type. So the real world scenario is of the abstract data type, and the implementation of how we do it in computer science with some programming language is the data structures. So that's what we're going to do. Okay? There's also linked lists, for which we use tons of pointers. Right? So linked lists, for the stacks and the queues, we're going to use arrays. For the bag, we're going to use arrays. For the linked lists, we're going to start doing a whole bunch of pointers. Then we're going to talk about trees and all kinds of different things. What's a tree? Well, it looks like this, right? And this thing here can be written using an array, or it could be written using a linked list. And you don't know anything about linked lists, but it's basically just a bunch of pointers. All right, so that's the plan, okay? And a lot of these questions will come on a job interview, okay? A lot of these basic things that I'm talking to you about, arrays, you better believe that they're going to ask you questions about arrays in your job interview. You better believe they're going to ask you some questions about data structures in the job interview. So you got to know it. And if you don't know it, you're going to fail when you transfer, or you're not going to get that job, okay? That's the name of the game. And the more you do it, the better you get at it. And that's what I'm saying, that if you do a problem one time and you're not sure how to do it again. I know you have lots of time. You don't take any of the classes, right? This is the only class in the world for you. Just being sarcastic. All right? Don't worry. I got you. So, if you have any questions, come see me in the office hour. Send me your questions. If you get stuck on anything. As you can see, we are already on what? P60? So if you're far behind, you already know how many hours it takes to finish this class. What is it, like 110 hours? Make sure you keep up with the work, do the due diligence, so that you can be happy at the end. Happy like a hippo. Okay? No, like a hippo. Okay, you can be like a bunny if you want to. Okay, so that's it. I'm going to head to my office hour and wait for your questions there.